What's up, everyone? Welcome back. Patrick here. Moving on to another word problem dealing with quadratic. So we're told this half pipe here can be entered from platforms on either side. So we could enter this half pipe here from this platform or this platform. Both of them have the same height. And we're also shown that this half pipe here, it's modeled by this quadratic. H equals 0.12x squared minus 1.08x plus 5.4, where x is the horizontal distance, so this over here, and then h is obviously going to be the height right there. Okay, so we're asked how wide and deep is the half pipe. So notice that this half pipe, it's above the ground, so this is like the ground over here, and we're asked how wide is it, and then also how deep it is, and then we're also asked how many meters would you travel horizontally for either one, a drop of 1.5 meters, or two, a height above the ground of 3 meters. So we'll get into the specifics of those. I'll show you what both of these mean on the diagram once we get there. Let's first start off with part A. How wide and deep is the half pipe? Now, notice that we can actually find out how high these platforms are above the ground, because notice that this quadratic here goes through both of these points. And so let's write this quadratic over here just for more reference. And notice that this is a quadratic in standard form. And so we could actually find what this intercept is here by plugging in 0 for the x values. And so when we plug in 0 for the x values, this goes to 0, this goes to 0, we get a height of 5.4 meters. So this here is 0 and 5.4. Now, why is that important? Well, it's important because now what we can do is find out where this other point is. We know that this point here has a coordinate of 0 and 5.4. Now we know that this point and this point, they both have the same height, but we don't know the x value of this coordinate over here. So that's what we have to solve for. We know the height is 5.4. And once we know that x coordinate, well, then notice we can figure out what the width is. It's just going to be the difference between this x value and this x value of 0. So the way we would do that, we would plug in 5.4 for h. To solve for that other x value, bring the 5.4 over, and then notice the 5.4s will have 5.4 minus 5.4, so they're actually going to cancel out. And so now we're going to end up with a quadratic equation over here, where the a value is 0.12, the b value is negative 1.08, and then the c value is 0. There's like a plus 0 here. Remember, whenever the c value is 0, whenever you have a quadratic like this in that format, ax squared plus bx, well, one of the intercepts, one of the x-intercepts of that quadratic is always going to be 0, because you could always take out an x over here. And so that makes sense because we're going to get a 0 right there. The question is what this other x value there is going to be. And so we can just plug everything into the quadratic formula. You could also factor this if you want. I'm going to use the quadratic formula because that's what we're focusing on in this section. So we'll have negative 1.08 plus or minus, and then we'll have negative 1.08 squared, right? B squared minus 4 times the a value of 0.12 times the c value of 0. And this is going to be all over 2 times 0.12. Well, notice what's going to happen. This is going to be positive 1.08. Then we're going to have plus or minus. Notice this entire term is going to go to 0 because we have that 0 in the bracket. So we'd have the square root of negative 1.08 squared, like that. And that's going to be 2 times 0.12. Well, if we're taking something, squaring it, we'll have a positive value, and then the square root of that, notice that it's going to be that same value right there, right? So like if we took the square root of, let's say, negative 3 squared, well, that would be like the square root of 9, which would be equal to plus or minus 3, right? So we end up with that same value here. The negative would go away. It'd be a plus or minus actually after we end up square rooting it. So that's what's going to happen here. We're going to square this, and then we're going to square root it. So we still end up with that 1.08. And so notice that what we would get is 1.08 plus or minus 1.08 all over 0.24. And so notice one of the solutions is going to be 0 over 0.24. And the other one is going to be 1.08 plus 1.08, which would be 2.16. That's going to be over 0.24. And this is going to give us 9. This is going to give us 0. So we got 0 as expected over here, but then we also got that other x value over here, and it is 9, like that. And so how wide is this half pipe going to be? Well, the half pipe, the width of it is going to be 9 meters. Okay, we still haven't found the depth of it, but the width of it is basically going to be the distance from this point to this point, which is going to be 9 minus that 0. Now, how can we find the depth of the half pipe? Well, what we can do, let me erase this over here just to visually show. The depth of the half pipe, if you think about it, is going to be the distance from this line, which is the top of the half pipe, to the most bottom portion, which is going to be the vertex of this quadratic over here. That's going to be the depth of the half pipe. Now we know that this line here, this dotted line, it has a height of 5.4. If we could find out what the height of this vertex is right here, then we could take the difference between that height and 5.4, and that's going to be the depth of the half pipe. Now notice that we have the two values right here of 9 and 0 that are on the same height of 5.4 on the same y value. So this vertex is just going to be the midpoint between those two x values, which is going to be 9 plus 0 over 2, which would give us 4.5. So we know that this vertex here is going to have an x value of 4.5. Now usually we find this axis of symmetry, or the x value of the vertex, by finding the midpoint between the intercepts. But really, you could find the midpoint between any x values that have the same y value. You could pick these 2 points, you could pick these 2 points, you could pick these 2 points. All of these, the midpoint of each of those pairs is going to give you that axis of symmetry. So because we have the 0 with a y value of 5.4, we have a 9 with a y value of 5.4, we could find the midpoint between 9 and 0 to get that axis of symmetry, which is 4.5. And then to get the height of the vertex, well, we take that x value of 4.5, and then we just plug it in here. Okay, and when you do that, what would happen is you would get 2.97 right here. So this here ends up being 2.97. So this point is 2.97 meters above the ground. This horizontal line is 5.4 meters above the ground. So the difference between those is going to give us the depth of the half pipe. All right, so hopefully this makes sense. This is kind of a complex question. You may have to rewind it a bit, rewatch it. I'm trying to do my best to explain it. It's a pretty tough one. But the depth here is basically the distance from here to here. And we know that this point has a height of 5.4. This point has a height of 2.97. So the depth of the half pipe is just going to be the difference between those, which is going to give us 2.43 meters, like that. And that's it for question A. So the width is 9 meters, the depth is 2.43 meters. Now moving on to part B. So part B in question 1, part 1 of part B, what they're asking for is, what's the horizontal distance for a drop of 1.5 meters? Now, what do they mean by a drop? They basically mean, let me draw another diagram here. This one's starting to get a little bit messy. So what they're saying is, okay, if we're starting at a height of 5.4 meters, well, a drop of 1.5 meters, 5.4 minus 1.5, is going to give us 3.9. And so what there's a drop of 1.5 meters, a vertical drop from 5.4 would give us a height of 3.9. And so we basically want to find the point. Okay, let's erase these points so you're not getting confused here. Of where the height is going to be 3.9 meters, right? A drop of 1.5 meters from 5.4 is going to give us a height above the ground of 3.9. And so what they're asking for, how far horizontally do you have to travel? We're solving for that x value to get to a height above the ground of 3.9, to go from a height of 5.4 to 3.9. Notice that there's going to be actually two x values that we get, this one and this one, but they're just asking for this first one. How far horizontally are you going to have to travel to get to a drop of 1.5 meters, and then you're going to come back up, and then you're going to get to that same height again on the other side of the half pipe. But really, they're just asking for that first x value, but when we solve, we're going to get two solutions. So what we do to solve for those two x values, plug in 3.9 here, and we're going to solve for the x values. Okay, bring the 3.9 over, we'll have 0 equals 0.12x squared minus 1.08x. 5.4 minus 3.9 would give us 1.5, like that. And then from here, you could take these and then just plug all of these variables into the quadratic formula. So we'll have negative 1.08, that's the negative b, plus or minus the b squared, minus 4 times the a value of 0.12 times the c value of 1.5, there's an actual c value in this case, all over 2 times 0.12, like that. And when you do all of that algebra over here, I wrote out all the algebra just because there's a lot of decimals under the square root, you'd end up with this over here, then the square root of that is this. And then the two solutions you would get here is 1.72, 7.28. Make sure you do this algebra on your own. Lots of decimals here, so make sure you're getting those same two answers. And so those are the two x values here that would give us that height of 3.9 meters, right? Or a drop of 1.5 meters. And so the answer to part B, or part B, part 1, is this 1.72 meters. That's how far horizontally you have to travel in order to achieve a drop of 1.5 meters, right? That's 1.72. It's the first x value here, and then this other x value, that other horizontal distance, represents when you come back to that height of 3.9 meters again. So that's it for part 1 and part B. Part 2 actually I think is easier because they're asking how far horizontally do you have to travel to get to a height of 3 meters above the ground. So notice here this 3.9 we had to kind of get from 5.4 minus the drop of 1.5. Well, now they're directly just giving us the height above the ground of 3 meters. And so that's going to be like here and here. So again, we're going to get two x values, but we're really going to be focusing on that first x value. Not really that second one, but we are going to get two solutions. And to solve for those two x values, we plug in 3 over here, 0, 0.12x squared minus 1.08x. 5.4 minus 3 would give us 2.4, like that. And then we could just plug in everything. Again, I could have actually kept that same quadratic formula written out initially and just change the c value, because everything else, sorry, this should not be squared, this should be squared. Everything else is staying the same, like that. And this is going to be all over 2 times 0.12. And when you do all of the algebra here, you'd end up with this under the square root. When you do all this, you'd end up with this, and then 1.08 minus 0.12 over 0.24 would give us 4. 1.08 plus 0.12 divided by 0.24 would give us 5. So this here, this x value would be 4. This x value here would be 5. Both of those x values would give us that height above the ground of 3 meters. And we would just focus on that first x value right there. So how far horizontally do you have to travel down the half pipe? Horizontally, you got to travel 4 meters in order to get to a height above the ground of 3 meters, right there. Right, so fairly tricky question, lots going on here, but I did want to cover it. Hopefully you understood it. It was a kind of tough one, so you may have to watch it again to really comprehend everything, but hopefully you got it the first time.